Hello everyone, my name is Shyam Chauhan and in this lecture we are going to cover question number 2. In question number 2, we have to represent the following situation in the form of quadratic equation. Quadratic equation is of the form ax square plus bx plus c equals to 0. We have x as the variable is x. We have only one variable in the equation. We have only one variable, so whenever we will only assume one variable to make the equation of the form ax square plus bx plus c equals to 0. Let us start with the first part. The area of rectangular plot is 528 meters square. The length of the plot is one more than twice its breadth. We have to find the length and breadth of the plot. So the statement that is the length is one more than twice its breadth. If we observe, we have length that is dependent on breadth, that is length is one more than twice its breadth. Length is one statement, and then we have other statement that is one more than twice its breadth. So if we assume breadth as x, then length is one more than twice its breadth, that is twice its breadth plus 1 is equal to length. So we have to assume the breadth equals to x and length will be 2x plus 1. Let's assume breadth is x meters. Breadth equals to x meter, so length is one more than twice its breadth. Twice its breadth plus 1, that is the length. Now we have the area equals to 528 meter square. Area of rectangular plot equals to length into breadth, that is equals to 528. Length is 2x plus 1. Breadth is x equals to 528. 2x square plus x equals to 528. We have x square plus x minus 528 equals to 0, which is the required quadratic equation. 2x square plus x minus 528 equals to 0, where x is the breadth in meter. Part 2. The product of two consecutive positive integer is 306. We have to find the integer. Product of two consecutive integer is 306. Two consecutive integer, we can take 2 and 3 as two consecutive integer, where 2 is smaller integer, 3 is larger integer. We can take 57 and 58, that are the consecutive integer. 57 is smaller integer, 58 is larger integer. If we observe in 57 and 58, 57 is smaller. If we assume 57 as x, then we can get 58 as x plus 1, because if we add 1 in 57, we will get 58. So we can assume x is the smaller integer and we can get the larger integer by x plus 1. So let's assume the smaller integer is x, the larger integer, smaller integer is x, then larger integer will be x plus 1 because these two are consecutive integers. The statement product is 306. Product of the consecutive integer x into x plus 1 equals to 306. Simplify this, we have x square plus x equals to 306. X square plus x minus 306 equals to 0, which is the required quadratic equation, where x is smaller integer. Rohan's mother is 26 years older than him. The product of their ages in years is 3 years from now will be 360. That is, product of their age 3 years later will be 360. You would like to find the Rohan's age. In this case, Rohan's mother is 26 years older than him. If we assume the Rohan's age is x years, then Rohan's mother, which is 26 years older, Rohan's mother's age will be x plus 26. You would like to find the Rohan's present age, so let's assume Rohan's present age is x year. If Rohan's age is x year, his mother's age will be x plus 26 because his mother is 26 years older than him. Now the statement product of their age 3 years from now will be 360. So 3 years from now age of Rohan will be x plus 3 years. Age of his mother will be x plus 26 plus 3 years, that is equals to x plus 29 years. The product of their ages 3 years from now is 360. So we have age of Rohan, that is x plus 3 into age of his mother x plus 29 equals to 360. Simplify this, we have x square plus 29x plus 3x plus 29 into 3 equals to 360. Take everything on one side, we have x square plus 29x plus 3x plus 87 minus 360 equals to 0. Simplify this, we have x square 29 plus 3 is 32 plus 87 minus 360 is minus 273 minus 273 equals to 0, which is the required quadratic equation, where x is present age of Rohan. Part 4. A train travels a distance of 480 km at uniform speed. We have the formula speed equals to distance upon time. We can write distance equals to speed into time. If the speed of train had been 8 km per hour less, then it would have taken 3 hours more to cover the same distance. We need to find the speed of the train. Let's assume the speed of train is x km per hour. We have speed equals to x, distance covered 480 km, and let's assume time taken is t hours. We can make the equation, that is distance 480 equals to speed into time. Speed is x into time is t, which is the first equation. Subject t from the equation, we have 480 upon x. Now if the speed would have been 8 km per hour less, we have initial speed x minus 8, then the time taken would be 3 hours more. Initially we have time t, now time t is 3 hours more if the speed is 8 km per hour less. Distance covered is same, that is 480 km. Now if we make the equation, that is distance equals to speed into time, distance 480 equals to speed x minus 8 into time t plus 3. Put the value of t from the equation 2. We have 480 equals to x minus 8 into 480 upon x plus 3 because of equation 2. Simplify this equation. We have 480 equals to x minus 8. Take x as LCM. We have 480 plus 3x. X minus 8 and 480 plus 3x upon x is in the multiplication, so we can send x to the other side. We have 480x equals to x minus 8 into 480 plus 3x. 480x equals to 480x plus 3x square minus 3840 minus 24x. Take everything on one side. We have 480x minus 480x minus 3x square minus 3840 plus 3840 and plus 24x equals to 0. For 80x will get cancelled. We are left with minus 3x square plus 24x minus plus 3840 equals to 0. Multiply both the side with minus sign. We have minus 3x square plus 24x plus 3840 equals to minus 0, that is equals to 3x square minus 24x minus 3840 equals to minus 0 equals to 0. Divide equation by 3. We have x square minus 8x minus 1280 equals to 0 divided by 3, that is equals to 0, which is the required quadratic equation, where x is speed of train in km/h. From next lecture, we will start topic number 4.3, solution of quadratic equation by the factorization method. Thank you.